Another wonderful session in our mission midterm series. Today it's optical phenomena in one shot. Yesterday we did part 1 of human eye and the colorful world. I told you this is more like Bahubali, the beginning yesterday, right? Today it's more like the conclusion, right? So this is the human eye and colorful world, the conclusion. Part 2, a full shot, a full one-shot session of all the optical phenomena we see around us. Which means this becomes another very important session because human eye is a big chapter. We are covering it. I just don't want to stuff everything in one session. That's why we broke it in 2. So that you can learn better, right? Good evening, hello, namaste, sat shri akal, assalamu alaikum. What do you say? Are you excited for this session? Come on, tell me. Optical phenomena, everything we'll understand, don't worry. Some of the things we have already done before. A few of the things we'll do for the first time. Yes, excited? Ready? Alright. Chalo, theek hai. Very excited. Bahut achhe. What do I want? I want you to be alert. I want you to be attentive. I want you to make your running notes. Because don't worry, I'll give you my notes. But your notes are equally important because today 7 PM session mein we'll talk about how to be more efficient in the lot of techniques, right? How to be smart in studying. So this session we have after this. Don't worry, hai na? Good evening. Clearly audible and visible, I'm expecting because you are giving me a thumbs up, right? So I think I'm clearly audible and visible, which means we can start. What do you say? Oh, nice, Chitra. Same to you, yeah. Alright people, it's a one shot, means we'll be focused. We will not distract a lot from the session, right? We have to finish it in 45 minutes. Usually I don't want you to be sitting for a long duration, na? Sabko thoda break chahiye hota hai. So that's why. Okay, visible and audible. Thank you, Anoop. Chalo, alright. Let's begin. You all are seeing one video in the starting of every session nowadays, right? Good evening. That video is about ANTHE. I won't repeat all the things. I'll just tell you important things. That is scholarships, it is full scholarship available, all India rank, cash rewards and 4 mock tests. Means the moment you register on this, you will get 4 mock tests free for ANTHE. What is ANTHE? It is Aakash National Talent Hunt exam. Very prestigious all India level exam. It is important. Online it is happening from 5th to 13th of November. Offline it is happening from 6th to 13th of November. And registration is free. Muft hai bhai, hai na? Yes. Yeah, it's okay, Chitra. It happens. I understand you guys are getting busy nowadays because of school and exams. This is also for exams. Even if you miss, no, my thing is watch it afterwards. Okay, but it will be beneficial, right? Cha, smart board chahiye. What do you think? Smart board is better or this one is better? Smart board pe thoda kya hai na, kabhi animation and all these things do not look that good. We will bring smart board session also in between. Don't worry, hai na? Yes. Alright, so make sure you enroll it. It is free. And I would say if I were at your place, I would have enrolled. Padhai, kai baar, you know, sometimes we don't enroll thinking, Arey yaar, when will I study? I won't get time. Maybe I shouldn't enroll. Nahi, do enroll. Even if you feel you won't get time, do enroll. Because at least you will see what an all India level test look like. Hai na? Do it. Hai na? It's okay, Chitra. Yes. Ye acha hai na? Kabhi. Blijash, right? ठीक है. This is good na? बढ़िया. Okay. Chalo. What we are doing? Sir, we are doing mission midterm where we are targeting 100% in the midterm examinations because these are only midterm examinations. We are planning for a long road, right? For a bigger target, the boards. 100% is the target. Target छोटा रखने का क्या फायदा? You can't keep a target like 80% ना. Sir, मेरा target है 80% लाना. It's not a target. If you give your 100% and then get 80%, it's okay. Sir, I gave my best, I got 80%. Okay, I know what is my mistake, what I have to do. But if you target 80% and then get 80%, kya fayda? Target for 100%. Then see. Put your efforts 100%. Then see what happens, right? So in this, we'll give you all notes in PDF, revision, exam focused question, mock test, one shot and doubt solving. Doubt solving session, I told you, very important. Come prepared, come revised. And for all of this, you should be a subscriber to the channel. Means people who are new, make sure you subscribe for the channel, right? That is important. Yes, starting quickly. Syllabus for ANTHE, your class syllabus only. previous class and this class syllabus. Bas. Yes, Innovative 26, this is live. Obviously live. Already subscribed. Very good. Chalo. Now, let me start you with one very simple question. How many of you have seen those moon images? Remember, Neil Armstrong went to the moon, and you might have seen those images which we have of people standing on the moon, right? Have you seen those images? You have, no? You have seen those images? Right? So let me ask you one question. It is so scary. Acha. Right? So let me ask you one thing. Why does it look like astronauts always take pictures of moon at night? It feels like this, no? कि जब भी जाते हैं रात होता है वहाँ पे. Whenever they go, it's always night. Always they click pictures in night. Why? ऐसा लगता है ना? Did you have also this question sometimes? कभी-कभी लगता है, right? Oh, nice. Tomorrow your science exam is there. Means watch carefully. Everything will revise today of human eye, है ना? You feel like this. Sir, always it is right. Nice. Some of you might know the answer, but we'll talk about this in detail, right? Moon is black in color. No, right? है ना? Wondered. So this question, I will not answer it right now. But in this session, I'll teach you in a way where this question you can answer by yourself. In the end, I'll explain it to you. Kyun? ठीक है? Right? Nice. TBS cast. Very good. This is half of the answer. We'll look more into the details of why. Chalo, ठीक है? So this is my session for today. And I'm giving you a heads up where I'm going to discuss what. The Colourful World mein, today we'll discuss about dispersion. Okay, we'll talk about rainbow formation, we'll talk about atmospheric refraction and scattering of light. Which of these topics you feel is the most difficult and you are most scared of? Nice, Apurva, good. Because Earth cover moon nahi Kunal, not true, zaruri nahi hai. Nice, Shivansh, very good. Which of the topic you feel is the toughest? Now, I'll answer this, don't worry, है ना? Yes, Muskan, prism आएगा. पहले में ही आ जाएगा. Formation of rainbow, dispersion. Number 4, scattering of light. Sir, B, rainbow, है ना? So all of you have at least one of the topic you feel which is difficult. We'll cover all 4 nicely in good detail. We'll revise everything. Means you have to be alert. ठीक है? चलो start कर रहे हैं हम लोग. We'll starting with dispersion. Okay? Ready? Excited? Come on, let's start. So dispersion. See, we all remember dispersion as what? If I want to define dispersion, we call dispersion as, so dispersion is the splitting of light. Yes. But before splitting, we also need to understand why it splits. So let's talk about a device. See, we have seen we have seen glass slabs a lot, है ना? We have seen glass slabs a lot, and glass slabs are easy. Whenever any ray falls on it, it refracts, it bends, correct? It bends, and then it goes out. It bends again, and incident and emergent ray are parallel, right? Correct? है ना? Light का बिखरना. It's okay, Shruti. Right? This is the incident ray. This is the emergent ray. Incident ray and emergent ray both are parallel. We all know this, right? So glass slab mein to this happens. But prism is not exactly like glass slab. Prism is a triangular glass slab, right? It's like this. So how many faces are there? Sir, 1, 2, 3, 4, 5 faces are there in a prism. Yes, correct, hai na? Yes, prism has 5 faces. All right. Now this angle this triangles, this top angle is what we call as angle of prism or A. All right. Fine. This is the lingo. All right. Now this is air, this is glass. Normally prisms are made of glass, and this is air again. Okay, sir. Bahut badhiya. Fine, not a problem. Now watch carefully how a light enters this, and it is how different from a glass slab. Okay? Nice. 5 faces. Very good, Aarti. Watch. First is this. This is the incident ray, right? This is the incident ray. Now we all know the incident angle is measured from incident ray and the normal, not the surface. Because I'm telling you, in the questions I'll give you, there is a ray falling on the prism making an angle of 30 degrees with the face of the prism, with the surface of the prism. I will not tell you how much is the angle of incidence. I'll just tell you 30 degrees from the surface of the prism. What will be the angle of incidence? Come on, tell me, anyone. Jaldi. What do you think will be the angle of prism? How much? Come on. Batao. Oh, hey Pushpa. Yes. What do you think will be the angle of incidence in that case? 60. Very good, Priyanjan. Right? है ना? Very good. Anil. Bhagirathi. Nice. है ना? 60. Not 90. Anil 90 नहीं होगा. It won't be 90. It will be 60. Why? Not 90. 90. Not 90, guys. If I told you that light is falling on a surface which is making 30-degree angle with the surface, so angle of incidence is always measured from the normal. What is normal? Normal is that imaginary ray which is 90 degrees to the surface. If ये total 90 है, if this is 30, means this is 60 degrees. No, so 60 degrees become the angle of incidence. All of us should be very clear with this because I am going to confuse you a lot in future in these kind of questions. I am just telling you upfront. ये करने वाला हूँ मैं. You should all know this, right? Yes. हाँ. ठीक है? So it will be 60. चलो ठीक है. That is just one segment I covered. So angle of incidence. अच्छा ठीक है. Light is going on this first interface. Light is going from air to glass. मतलब from rarer medium to a denser medium. It should bend towards the normal or away from normal. Blijash, Adil sir is not well nowadays, so don't worry. He'll be back very soon. Correct? है ना? Towards the normal, not away, Mishti, not away, towards the normal. Sir, why towards? यहाँ पर क्या हुआ था? In the glass lab, what happened? Light was going from air to glass. So from rare to denser medium, when the light goes, it bends towards the normal. So that is why light is going to bend towards the normal. Angle of refraction will be smaller than the angle of incidence, right? है ना? We understand this? Very easy. Easy है. And don't worry, light का भी हम लोग one shot करेंगे. This is human eye first, है ना? ठीक है? Yes. चलो, इतना clear है? अच्छा, next question. Sir, क्या हमेशा ये वाली ray, this refracted ray, will it be always parallel to the base? Not necessarily. जरूरी नहीं है ना? But अभी हम just for the sake of understanding we are doing it. ठीक है? चलो. So the first refraction happened from rarer to denser means light bend away from normal. चलो कोई बात नहीं. Now this came second interface. This वाला. Here light is going from glass to air again. है ना? Light is going from glass to air again. Means light will bend away from the normal. Right? अच्छा, what is the base of the prism? Base of the prism is this. Who asked? Asta. Asta, base of the prism is where you make the prism sit, है ना? नीचे वाला face, उसको बोलते हैं prism, base, है ना? Yes, midterm is coming soon. That's why we are doing this. This is for your midterm only. Yes. Didn't get PDF of yesterday's session. 1 or 1.5 days delay happens, Adi. It's okay, but you will get it. Pakka. हाँ. Right? Yes. So on the second interface, light is going from glass to air. It will bend away from normal. See, people usually end up remembering this diagram. It is not, you don't need to remember this. Everything is visible. Everything is from the basics only. है ना? Yes. No, rectangular नहीं होगा आस्था. अच्छा, oh, base will be rectangular. Right, correct. So base will be rectangular. उसके ऊपर I have this one layer, this. उसके ऊपर I have another layer like this. हाँ, now this is the prism, right? One layer this, one layer this. हाँ, good. हाँ, nice. Exam portion was light. Abdullah will cover light. After this, light का भी one shot होगा. Don't worry about that. पक्का. Why ray bend downwards? अच्छा, Jenny, you are asking why the ray bend downwards. See, on this I won't spend a lot of time. In the app, there is one analogy given to you like of a car tire. So from that you can understand. But it bends because I would say its speed increases. If the speed of light decreases, it bends towards the normal. If the speed of light increases, it bends away from normal. ठीक है? Just remember this much now. है ना? Neeraj, yes, definitely. है ना? Okay. अरे वाह भगीरथी, very good. Priyani, electricity, it is not covered in the mission midterms, but electricity we will do. I mean, normally for class 10th we will do, but not very soon. After this, it is light one shot, and after that electricity. Yes, cataract pushpa kuch nahi hota hai. Cataract is the haziness, or I would say the lens becomes opaque. That is cataract. उसके लिए सर्जरी करना पड़ता है. ठीक है? Nice. All right. चलो. Come on. So understood. Very clear with how this light ray is behaving in a prism. बहुत बढ़िया. चलो. Now watch. Sir, in glass slab, the incident ray was parallel to emergent ray. Correct, है ना? Because incident ray was also going straight. Emergent ray was also going straight, but there was only this lateral displacement, है ना? This was emergent ray. This would have been the incident ray. Incident ray क्या होती? ये होती अगर glass slab नहीं होता. And this is the emergent ray. दोनों के बीच में, if you tell me these are two parallel lines, angle between two parallel lines is how much? Cataract. Aditi, yesterday's session. Watch yesterday's session. We had discussed about all the defects of vision. Yesterday was also one shot of human eye. Make sure you watch that. Jenny, this will take me time to explain this. Today, if I do that, I'll be away from this session. But make sure BYJU'S app पे ये है. And someday, don't worry, I'll talk about this. But light के session में मैंने किया हुआ है ना, Jenny, light का proper sessions हो रखे हैं. We have done light sessions before. This is there in that. Okay? Equal angle. No, not 180. 180 will be if one parallel line is like this and one line is like this. But here, parallel lines are these. Incident ray is like this. Emergent ray is like this. Angle is 0. So angle between two similar direction parallel lines is 0. Okay, है ना? Equal. Or I won't say 0. I won't say equal also. I would say 0. ठीक है? Yes, got it? चलो, ठीक है? But here, watch. Incident ray. Without this prism, incident ray would have gone like this. Just listen to me carefully, है? नहीं, 90 नहीं होगा अनिल. Right? Now it won't be 90. It won't be 90. क्यों नहीं होगा 90 ना? देखो, incident ray is like this. Emergent ray is also like this. दोनों lines parallel हैं. Like this. Angle will be 0. Correct? So now, yes, है ना? Thank you, Dhruv. Without this prism, incident ray would have gone straight like this. But because of this prism, incident ray is going like this. Right? Can you tell me how much the light ray bent? Without prism, light ray would have gone straight. But now it is going this, in this manner. In this, light ray is bending. It is bending angularly. There is an angular bending, है ना? So that's why we call, this is called as angle of deviation. The reason I'm doing all this effort is for you to understand that why this name came, angle of deviation, because light deviated. Light would have gone straight. Now it is going here. This is an angle with which is deviated. That is the angle of deviation. Got it? Yes? Hey Shruti. I'm not sure. I forgot the question. But you can ask it. है ना? Angularly मतलब होता है angle पे. है ना? It would have gone straight, but with an angle, it bent. It deviated. So this is what we call as. समझ नहीं आ रहा है? मुस्कान ध्यान से देखो, है ना? देखो, prism नहीं होता. If prism was not there, light ray would have gone straight. है ना? Like this. Light ray would have gone straight if there was no prism. But if prism is there, light ray is actually bending. है ना? Finally, light ray is coming out like this. No, this is the emergent ray. So light ray emergent is like this. Prism नहीं होता, तो incident ray would have gone like this. So this is the bending that happened. Incident ray and emergent ray, there is this angle in between. This is what we call as angle of deviation. है ना? Mishti, telegram, I'll tell you, don't worry. हाँ, Tabrez sir, we'll talk about this. You are good and we'll talk about this, है ना? No, it is not equal to emergent ray. It is not equal to emergent ray. See, this emergent ray is this one. No, this is E. This is angle of emergence. This is angle of deviation. I would say not always. Not always, okay? Yes, chalo, ठीक है, fine. So, right now just understand this. There is something called as angle of deviation. Alright, sir, alright. Now comes the question of color and deviation. We all know that white light is not one color, right? All of us know, है ना? Clear? Hey, Anna. So, all of us know that I equals E, Aditi, it's only one particular case for the minimum angle of deviation and when the beach ka ray is parallel to base. Not always, है ना? I equals E is not true always, only for one particular condition. ठीक है? Yes? Sign, अच्छा, sign is called as delta. This is the delta sign for angle of deviation, right? Angle of deviation. ठीक है? अच्छा, now, let's come back. White light is not one color, right? है ना? It's a 7 colors. In visible spectrum, it's like a spectrum of 7 colors, है ना? We call it VIBGYOR. Violet, indigo, green, blue, white, VIBGYOR. Green, yellow, orange, red. हाँ, ठीक है? Right? Yes. Oh, Shruti, yes. That's a good question. Don't worry. I'm bringing a session on that very soon. Right? Nice. Correct? Spectrum, hai na? Acha, nahi, that is also a delta. This is also delta. This is also delta, hai na? Right, chalo. Okay, now the thing is, every color does not bend equally. Listen to me carefully. Every color does not bend equally. Right? Correct? Ha, sir. Okay. Now, why? Because red bends the least and violet bends the most. You know, this in our light session, I have explained you very clearly this thing, but today I won't go that deep, but I'm just telling you. Just remember it like this. Red bends the least, violet bends the most. Bhai kya hai? Vibgyor hai na? Listen, it is Vibgyor na? V-I-B-G-Y-O-R. Red. Red bends least, violet bends the most. Okay, fine. Yes, it is because of wavelength. Yes, nice. Okay, good evening, Abhilash. Right? So that is why if red is bending the least, red ऊपर रहता है. If violet is bending the most, वो नीचे रहता है ना? What is bending? भाई, if I ask you, angle of deviation for violet will be more than red, na? Angle of deviation will be more for violet compared to red. Why? Because red is deviating the most. Red is deviating the least. ठीक है? Yes. इतना भेदभाव क्यों? हाँ, it is universal proportional wavelength. Correct. Right? है ना? Because colors हैं, इनका wavelength अलग-अलग है. Right? So, different colors bend through different angles and rays of each color emerge along different path. Right? मतलब refraction ही अलग होता है. Bending of different colors is different. But they come out differently in prism. In glass slab, they all combine. Right? In glass slab, they all combine. Spectrum मतलब क्या होता है? A series of colors, right? A continuous band. एक band हो गया. Violet का band, indigo का band. So this all bands combined are what we call a spectrum, right? Nice, correct, Aditi, very good. So rays of each color emerge along different paths. Okay, hello. Disha, I'll come to this question. By the way, we had this session. Why rainbows are circular in shape? We have a session on this same channel. Please make sure you watch it, है ना? Yes, Pushpa, definitely, I'll do it. Chalo, theek hai. So you all told me this. White light is composed of all wavelength, and this is simple. It's a Newton's disc, right? It has those 7 colors. When I rotate it very quickly, those 7 colors are I feel, acha, oh, it is white. This is what happens, okay? है ना? Yes. So this is how the white light is divided into spectrum of 7 colors. Fine. 7 colors we have written over here. Vibgyor. Now what is happening? देखो, violet has lowest wavelength. Sir, wavelength क्या होता है? See, what is this? It's a transfer wave. No, थोड़ा ऊपर जाएगा, थोड़ा सा. It will be slightly above what you know. But in our original session of this, है ना? In our previous session, the concept capsule session, we have covered this very nicely. Today, I'll give you a glimpse. समझना, दिक्कत हो तो वो session जरूर देखना, right? So this is what? This is a transverse wave. This is wavelength, right? The length of one wave, crest and trough. If you add both of them, this is the length of one wave. So this length, violet का ये length कम होता है, means violet has less wavelength compared to red. Red has more wavelength. So wavelength and speed increases, right, inside the medium. Correct? If you talk to me that, sir, inside the medium speed decreases, that is true. When refraction happens, when bending happens, speed of light decreases. That's okay. But speed of different colors or decreases differently. Red की speed सबसे कम decrease होगी, right? है ना? और you can say glass के अंदर red की speed सबसे ज़्यादा होगी and violet की speed सबसे कम होगी. What I'm saying? See, in air or vacuum, speed of all of the colors will be same. Let's say, है ना? In vacuum, speed of all colors is same. But when are they entering a glass medium? Speed of red will be more than violet. है ना? Yes. Ashish, in this session we'll talk about this. Don't worry, है ना? Okay. Aditya, this is how light is. This is what we observe. Right? हाँ मिस तरकार, I'll talk to you, don't worry, in this session only. चलो ध्यान से सुनो, ध्यान से सुनो. In glass, guys, this is very important. Lot of you get confused in this. ठीक है? Focus. Inside glass, speed of red is maximum and speed of violet is minimum in white light spectrum, है ना? In this color of this 7 colors, red का speed सबसे ज्यादा होता है, violet का सबसे कम होता है. Red का bending सबसे कम होता है और violet का bending सबसे ज्यादा होता है. Getting it? Are you getting it? Yes. चलो, ठीक है? So this is about wavelength and speed. Now this is about deviation. Take a screenshot of this. Come on, take a screenshot. This is very important. Take a screenshot. From violet to red, wavelength increases, speed increases inside the medium, and as you go from violet to red, deviation decreases. ठीक है? Yes. Oh, okay, Bhavish. Transverse wave इस तरह का होता है ना, जहां पे crest and trough होता है. जैसे you take a rope और rope को ऐसे कर दो. That is a transverse wave, right? Why is it that speed of light is low? See, today I can't cover it, but we have covered this in the session, in the light session, by the way, right? So make sure you watch that. क्यों कम होता है? We have talked about this, है ना? See, V equals F lambda होता है ना? But speed कितना होता है? Frequency into, and frequency remains same. So I have talked about this in that session, है ना? Summarize I'll do. ठीक है? चलो. Now what is dispersion? See, all this mehnat we did to come to dispersion. Splitting of white light into its constituent colors is what we call as dispersion. अब I am summarizing everything. Listen very carefully and note it down. देखो भाई, violet, VIBGYOR, violet की speed inside glass is minimum. Red की speed inside glass is maximum. Glass or a denser medium, है ना? Okay. Violet's bending inside glass is maximum. Red's bending inside glass is minimum. बस ये है summary, right? ठीक है? Yes. आशीष, ये अभी आंसर नहीं करूंगा मैं. Splitting of white light into constant colors, ठीक है? Right? So dispersion, how to define dispersion? When white light passes through a prism, violet bends the most, red bends the least, and white light splits into 7 colors. This is what we call as dispersion. याद कैसे करेंगे? Dispersion, disperse करना मतलब फैल जाना, है ना? So white light disperses into 7 colors. That is what we call as dispersion. Fine, okay. चलो. Now recombination. अच्छा sir, if once the light is split into 7 colors, is there a way to recombine it? What is a prism? आशीष बहुत लेट हो गया बताने के लिए. Prism यही तो है. It's a triangular glass slab, right? Yes. Yes, any colored light can pass through it, but we are talking about white color because we are talking about dispersion. Recombination of white light. See, white light, if once got split because of one prism, is there a way to recombine that? Yes, is there a way? हाँ, है ना? Yes, there is. Ria, I'll tell you in end of the session. अभी बताने का जरूरत नहीं है ना? हाँ, nice. It's 10th. Correct. Right? So, recombination can happen if you invert one prism and keep it in front. देखो, this first prism did the splitting. It created dispersion, right? Second wala prism, it created recombination. So, if you notice, all together, ये क्या है? It's a glass slab only, na? Bhai, it is a glass slab. Does dispersion happen in glass slab? No, sir. Why? Because light comes and goes back. So if there was a splitting happening, it will just recombine. So in glass slab, there is no splitting of white light. So these two prisms combined, they are working as a glass slab only. और कुछ थोड़ी हो रहा है यहाँ पे. Correct? Yes? हाँ. Right? In glass prism, Sheikh, in glass prism, it is happening. In other mediums also, it will happen. It should be triangular, है ना? Glass slab की तरह नहीं होना चाहिए. It should not be a glass slab. Bas, that is important. Yes, inverted prism can recombine, Shivansh. That's true. Right? Chalo. So this was dispersion. Guys, come on. We have to be quick. 6:30 is done. Yes. है ना? If one prism is there, dispersion will happen. If you have one prism and another one is inverted prism, recombination will happen and you will get the white light back. Bas, ठीक है? चलो, rainbow formation. This is for you everyone. Formation of rainbow. अच्छा, formation of rainbow. We are seeing so many colors. मतलब there must be some prism in the sky. What is that prism, right? What is that prism? कोई और कलर की लाइट पास होगी तो कुछ नहीं, there will be no dispersion, there will be simple bending. आस्था. Shruti, this question will be answered in the later half, थोड़ी देर में, in this session only. Raindrops, water droplets, correct. Yes, nice. It's 10th. Very good. है ना, water droplets. So who is acting as a prism? It is a water droplet, right? So water droplet के साथ क्या हो रहा है? It is acting as a prism in the sky. Now in water droplet what happens? See, when rays from sun fall on the water droplet, first of all dispersion happens, right? They get split into 7 colors. Then on this surface, this is internal reflection happening. People, you can watch this session also very clearly because you might think it's a heavy concept. I have done this very nicely in the session. On the second surface, it is internal reflection. Sir, is it total internal reflection? Is it total? No, it is partial. It is partial internal reflection. Okay. On the third surface, right? These are the 3-step process. On the third surface, it is simple refraction. है ना? Simple refraction. Okay. है ना? देखो English हिंदी mix रहेगा. You won't miss anything. I'm telling you. In English, we should be comfortable. By the way, future में नहीं तो मेरी तरह बहुत struggle करोगे. ऐसा नहीं करना. Right? चलो. तो ठीक है. In the rainbow formation, there is a water droplet acting as a prism. 3-step process hai. First, there is dispersion. Second, there is internal reflection. Is it total? No, it is a partial internal reflection. Third, it is refraction. Okay, 3-step process. Fine. Next, when light falls on a rainbow drop, we understood this. So I am taking only two rays now. है ना? Red or violet. I am taking only when rain stops. Yes, in the air there are raindrops. No, small water droplets. That's why it happens. Yes, Shivansh, correct. Yes, so in one drop this will happen. Yes, but there is not only one drop. No, there are multiple drops. Now violet के साथ incident ray and violet has a 40-degree angle. Incident ray and red color have a 42-degree angle. If you are having problem in this, I'm telling you again, there is a proper session on this we have done before this one shot. Watch it because basics kahin na kahin gadbad hai. You have to watch that, right? So 40 degree is between this incident light and the violet color. 42 degrees is between incident light and red color. I'm telling you these angles because these angles come in exams, right? And they ask red ka kitna angle hota hai, violet ka kitna hota hai. You should know. Violet is 40, red is 42. Okay? Yes. Yes, internal reflection hota hai. Yes, correct. Now there are not only one drop, there are multiple drops. So if I am looking at these raindrops, or I'm looking at that side, what I will see? I will see a rainbow as red drops from all these droplets are coming to my eyes, है ना? And violet from these eyes are coming to my eyes. And people who are wondering, sir, why rainbow is always semicircular in nature? This rainbow session, make sure you watch it because I have taken one prop with a cone. I have explained you everything, है ना? Yes. मुस्कान, इसको मैं आंसर कर सकता हूं लेकिन ना टाइम लग जाएगा. ये रेनबो का सेशन वी हैव डन प्रॉपर्ली. बहुत अच्छे से मैंने आपको कोन लेके समझाया हुआ है और अच्छे से मैंने आपको बताया हर ड्रॉप के साथ क्या हो रहा है. ठीक है, सो मेक श्योर वो पूरा 1 घंटे का सेशन है सिर्फ रेनबोस के ऊपर. दैट इज व्हाई आई एम टेलिंग यू वॉच दैट. अगर आज मैं ये सब करने लग गया तो फिर ये वन शॉट खत्म नहीं होगा. राइट आदि, वॉच द रेनबो सेशन. इंपॉर्टेंट. टुडे आई एम टेलिंग यू रेड एंड वॉलेट के बीच में रेड का होता है 42, वॉलेट का होता है 40 डिग्रीज. दैट इज इंपॉर्टेंट. ठीक है, एंड दैट्स हाउ वी सी रेनबो. मुस्कान, टाइप रेनबो फॉर्मेशन बायजूस, यू विल सी मी. 3-4 वीडियोस में मिल जाऊंगा मैं, है ना? यस, ठीक है. So yes, this is about rainbow formation. Rainbow formation is a 3-step process. First dispersion, second is partial internal reflection, third is refraction. And yes, there are multiple drops in the sky. From each set of drops, we are getting particular colors. कुछ drops ऐसी हैं जिनका केवल red light हमारे पास आ रहा है, right? There are drops in the sky from which we are getting only red color. There are drops in the sky from which we are getting only violet color. इससे क्या होता है? एक सेमी सर्कुलर बैंड बन जाता है. That's why you see rainbow like this. Okay, right? That's why. I have just repeated people. अगर अब भी दिक्कत है, if you still have a doubt, make sure to watch the rainbow session. Just write rainbow formation BYJU'S and you can just find me there. It's a 1 hour session. I have discussed rainbow with a proper experiment and you know, cones and everything. So make sure you watch it. Chalo. Next is atmospheric refraction. See, I want to spend more time on scattering because that is something none of you have seen before. Yes, you have watched, huh? Bahut achhe. So Sheikh, your answer, I think you don't have any doubt because of this, right? Hai na? So atmospheric refraction. So what is atmospheric refraction? We have covered this also before, right? Yes, by Saurabh Sir. Yes. Now this image or this video I have shown you before also in this session. यहाँ पर क्या हो रहा है? The thing I'm trying to mention over here is आँख के पीछे, just behind fire, whatever is there, it feels it is moving. Watch in these regions. It feels like flickering images, na? है ना? It feels like flickering images, right? है ना? Aditi, rainbow formation, 3-step process, angles are important, but इसके ऊपर अगर आपको चाहिए, watch that session. Please, my request to you is watch that session. Your whole doubts will be clear. But अभी क्या होगा ना? Time बहुत लग जाएगा यार. Okay? Yes? है ना? You can see the images flickering, right? हाँ. So why do they flicker? देखो भाई. Medium 1, medium 2, if it is bending towards normal, we all understand that it is going from rare to denser medium. Alright. Medium 3, again it is denser medium. Why? From medium 2 to medium 3, light is bending towards normal. That is also fine, right? Now, okay. How do you see any object? Sir, light falls on that object and then it comes to my eyes and I think there is an object, right? I see the object over there, है ना? Yes. Why does the flicker happen, है ना? So, अब क्या है? You are able to see the object because light from that object come into your eye. अगर उसके रास्ते में, if in the path of that ray there is this air ना, अगर ये air is going ding 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 like this, right? Means the image light will flicker, light will go sometimes here, sometimes here, sometimes there, sometimes there, right? This flickering is happening because in this medium, बीच के medium में, there is disturbance. That is why this ray is not able to come straight. It is coming ऐसे, right? Because medium के अंदर disturbance है. That is why, है ना? Ravi, why rainbow is curved? Watch the session, rainbow वाला, है ना? आज नहीं यार. Right? Okay? That's why I tell you guys, that's why I say, for one shots come prepared. नहीं तो one shots में हम first time अगर learn करेंगे, कैसे होगा? It's a whole chapter we are covering in one shots ना, right? है ना? Nice, Astha, same as Twinkling of Stars, okay? So atmospheric refraction, it is the same phenomena. By there, the image was flickering क्यों? क्योंकि there was fire burning. If fire is burning means hot air is rising, है ना? Hot air is rising. Now the light from that object is coming to my eyes, but in between there is this disturbance. What disturbance? Sir, hot air is moving up and down and cold air is doing all this. So that's why what is happening? That light ray coming to my eyes is getting disturbed. ऐसे. So I see flickering images. This is why. है ना? समझ में आ गया ना? है ना? So that is why. Nice, Sheikh, है ना? So guys, please listen to Sheikh also. He's saying, watch that video. Your all doubts will be cleared about the rainbow, है ना? Correct, Anup. So atmospheric refraction, same funda is in atmospheric refraction also. देखो भाई. Now always we used to tell you, देखो भाई, vacuum and air, refractive index is same. But you know what? I usually tell you it is almost same, right? Vacuum's refractive index is 1. Air's refractive index is 1.003. Slightly, but it is denser, right? Slightly only, but air is denser than vacuum. We all understand this, right? है ना? Correct? सही बात है? So gradually changing refractive index. Light is coming from the, let's say, stars, है ना? Aditya, not today. This question cannot be answered today, है ना? Refractive index not decrease, it increases, है ना? Oh, okay, Aisha. Sorry, my bad. I just remembered the account names and that's how I call you. I'm sorry if I do this again, but please understand, है ना? ऐसा हो जाता है. याद नहीं रहते बहुत सारे नाम कई बार. ठीक है? All right, Aisha? Yes. So that's why when light is coming from the star, and star is very far, no? Light is coming from the star to the earth. In the rasta, in the midway, it's all space, it's all vacuum. But near to the earth, there is atmosphere. And atmosphere, that is this air envelope. So you, me, we are sitting under this ocean of air, na? है ना? So this air is a denser medium. Okay, sir. Means when light comes from vacuum to air, it bends towards normal slightly. थोड़ा सा तो bend होता ही है. Okay. Now, what is happening? Actual position of star is this. Light from star comes to you because of refraction from vacuum and air. Now, air is not like single, है ना? Air के साथ क्या होता है? Air is in layers. And as you move downwards or as you move closer to the surface of the earth, air becomes denser and denser and denser. It means its optical density keeps on increasing. The optical density of air keeps on increasing. Means refractive index of air increases gradually as you go down towards the surface of the earth. Right? No, Neeraj, that's not true. I mean, you don't see it like that, but yes, they are. Right? So this is the actual position. Fine. But the problem is, like in that fire wala experiment, the fire wala image, here also, you have this 12, 13, 15 kilometers of air above you. Do you think it is like standing still? Aise, chup chap. No, it's not. No, it is going here and there. You have wind currents, right? You have wind currents. Your clouds move because of air. Matlab, there is a lot of disturbance happening. So what happens? What do you see? The apparent position. You are not actually seeing the actual position because light from star was coming. It got bent. Then it reached your eye, but your eye and with your brain, you have a tendency to believe light is coming in a straight line. Light kahin se bhi aa rahi ho, wherever it is coming, the moment it enters your eye thinks, acha, light, oh, coming from there. It always tends to believe light is coming in straight lines. So that's why we see an apparent position of stars. You know what? Correct, yes. I know your name is not, you're not Pushpa. I just forgot what you wrote over there. So I'll call you Pushpa again. Sorry for this. Yes, air is not statue, yaar. Hai na? So that's why apparent position we always see of the star. Now the thing is, there are varying physical conditions of the atmosphere. Guys, this word is very important. This is what we write in exams. Because of varying physical conditions of the atmosphere, right? Yes. Correct, Dheeraj. Nice. Yes or no? That's true. Wherever there is gravity, atmosphere is there. हाँ, ये हो सकता है कि that atmosphere is not like our earth. Toxic atmosphere हो क्या पता है ना? That's why. All right. So varying physical conditions of the atmosphere. Oh, Bhavish, I'll try to remember. अच्छा, you are Aisha, you are Bhavish. I'll try. Okay. So this is a very nice demonstration of how you see the stars. क्या बोलते हैं इनको? हिंदी में क्या बोलते हैं? टिमटिमाना, है ना? What is twinkling? That rhyme we all used to learn, twinkle, twinkle, little star, right? This is what Timtimana, twinkling of stars. Why they twinkle? Because the physical conditions are changing. Atmosphere mein airs are going here and there, here and there, here and there. So apparent position of star keeps on shifting here and there, here and there, here and there. And that's what you see. You are looking at star. Star abhi yahan hatke yahan chala gaya, fir yahan chala gaya, fir wahan chala gaya. This is what twinkling is, right? Okay, Timtimate tare. हाँ, yes, है ना? गजेंद्र दिन में ambient light इतना होता है स्टार दिख ही नहीं पाता है, right? So this is what we call as twinkling of stars. Now next question, important question. भाई अगर if sir this is true, why not planets twinkle? Planets क्यों नहीं twinkle करते हैं? भाई stars तो करते हैं, है ना? I'll tell you two things. देखो, star first thing is very far. जो चीजें बहुत दूर होती हैं, the things which are very far, they appear small. You agree, no? You bring your finger close to your eye, it will look big. You take your finger far from you, it looks small, है ना? Things which are very far from you, they appear smaller compared to things which are closer to you, है ना? Nice, आस्था, है ना? Yes. आदित्य सन से मून पे आई और रिफ्लेक्ट होके हम पे आ गई. They don't absorb light, भाविश. They emit light. Stars, sun क्या है? Star ही तो है, right? हाँ, yes. मुस्कान, it's a parallax thing. इस पे वीडियो है, right? So why don't the planets twinkle? Planets is closer to us compared to star. All of us agree. भाई planet तो क्या solar system में है ना? Venus, Jupiter, or we all see them. They are in our solar system. Stars are दूर, very far, right? So that's why star is very far, very small. Planets are near, they are bigger compared to stars. Okay. Now next thing. अब क्या हो रहा है कि the stars are seen as point sources, while planets are seen as a collection of point sources. Now notice, और मैं इसको एक बार समझाऊंगा. If you are not able to understand clearly, I would suggest again watch this session. इसको मैंने समझाया अच्छे से बहुत. देखो, star is one source. Notice over here. यहाँ पे ध्यान से देखो. Star क्या है? एक source है. मैं जो बना रहा हूँ ये red वाला, है ना? Star is one source of light. अब one source के साथ क्या होता है ना? There is one point. If position of this one point keeps on changing, you will notice it, है ना? लेकिन let's say there is a body, so I can imagine that body to be like multiple point sources. So planets are not actually one single point source of light. Planet क्या है? बड़ा है ना? Planet बड़ा है. इसका मतलब I can imagine planet to be like multiple point sources. Assume, है ना? Planet is like multiple point sources. अब इसमें से if 2-3 points go here and there, बाकी तो दिखते हैं. So on an average, the light coming from planet remains the same. So you don't see them twinkling. Getting it? Important. ये बहुत जरूरी चीज है. स्टार्स क्या है? बहुत दूर है, बहुत छोटे हैं. इट्स लाइक अ वन पॉइंट सोर्स ऑफ लाइट. प्लैनेट क्या है? बहुत पास है, थोड़ा बड़ा है. इट कैन बी इमेजिन लाइक मल्टीपल पॉइंट सोर्सेज ऑफ लाइट. नाउ फ्रॉम वन पॉइंट सोर्स अगर उसका लाइट ऊपर नीचे हुआ, इफ लाइट गोज हियर एंड देयर, इमेज विल गो इधर उधर. दैट वन सोर्स हमको दिखेगा इधर उधर होता हुआ, राइट? वी कैन सी दैट वन सोर्स गोइंग हियर एंड देयर. बट दिस मल्टीपल सोर्स, 5 सोर्सेज लेट्स से, if 2-3 just go here and there, at least average में whatever light is coming, that is still the same. That is why, है ना? Yes, right? Correct? हाँ, चलो. So that's why. Next question: are we seeing the real sun in the sky? The answer is no, because stars also you are not seeing the real stars. You are seeing an image, right? We all understand that their apparent positions, right? Correct? So that's why. You know what? We see an advanced sunrise. Yes, we see an advanced sunrise. What is advanced sunrise? Same concept hai, like the star thing. By actual position of sun is, let's say, here, right? Light from sun takes 8 minutes to come to earth. So when it reaches the atmosphere, it bends towards normal. Now refractive index gradually increases as you go down towards the surface of the earth. Means light keeps on bending towards normal, towards normal, towards normal, towards normal, until it reaches your eye. इसका मतलब when the light reaches your eye, सोचो, just focus over here. When it reaches your eye, the apparent position seems to be here. मतलब sun in reality is not above horizon, it is below horizon. It is the light from the sun is bending and reaching your eye, that you feel अच्छा, it is there. This is the apparent position of sun, right? This is advanced sunrise, we call it. Sunrise समय से पहले, right? So that's why sunrise happens about 2 minutes before. And this we have covered in the session. I told you how on Burj Khalifa you can see 2 sunsets in that session. Delayed sunset, same thing. Real sun is actually set, but the thing is, light from that sun is reaching your eye after coming from all the atmospheric layers, and you can see an apparent position above the horizon, and that's how you say, अच्छा, अभी तो time है. Sun is not actually set, but it is set. Again, 2-minute delayed sunset. Got it? So what happens because of atmosphere? We see advanced sunrise and delayed sunset. Okay? Yes. Fine. हमको 4 minutes ज़्यादा sunlight देखने मिलती है. You can say that. All right. So this was about atmospheric refraction. Now let's talk about scattering of light. Now focus, because none of you, I have taught this before. This is the first time I'm teaching you. Scattering of light. Now the question is, if light can travel through space, why the space looks dark? What is the color of space? I have given you one shot, if you remember, right? On the channel, I have given horizon होता है. अच्छा, horizon क्या होता है? If I tell you, ऐसे कभी बीच पे गए हो? Whenever you have been to a beach, you see wherever your eyes can see. जहाँ पे सूर्य अस्त होता है ना, फलक बोलते हैं हिंदी में, फलक, है ना? हाँ. Have you seen that shot? The shot, why space is dark? I have given you one shot on the channel. Anybody has seen that shot? Right? Hello. See na? So Asta, you have seen. Very good. Right? Dheeraj has seen. Very good. Right? So in that shot, I was trying to explain you the same thing. Why space is dark? भाई स्पेस में लाइट है. हाँ सर, लाइट तो है, बिकॉज सन इज देयर. सन की लाइट स्पेस से तो आ रही है, राइट? इट इज कमिंग फ्रॉम द स्पेस ओनली, राइट? Definition of advanced sunrise and delayed sunset. Because of bending of light from the atmosphere of earth, we see the advanced sunrise. Means the real sun is below horizon, but we see the image of sun above horizon. That's how we see advanced sunrise, and that's how we see advanced sunset. है ना? ठीक है अदिति, यही आंसर. Right? So that is why, if light can travel through space, why Does the space look dark? The answer is scattering of light. Yes, answer is scattering of light. अगर आपने वो shot नहीं देखा है, if you haven't seen that shot, make sure you watch that shot. People, I'll tell you one thing. See, people who are regular, who are coming ideally to every session, they are watching the shots, whatever we are telling you, you are not facing problem. But people who are not regular, I understand you are also busy and it's okay. What I'm saying is make sure to watch the session, not miss any session, because we cover everything. One shot में क्या होता है, अपने को लगता है कि इतना सब कुछ है क्या? It's not. The way we have taught you, it's all simple. That's why. Scattering, the absorption and re-emission of light rays by the particles of medium. अब क्या हो रहा है? Light, the white light from sun is coming, है ना? In between we have atmosphere. It scatters the light, right? And that is why we see colorful sky. हमको लगता है sky is blue, but outside it is black. Space is black, right? है ना? Nice. Correct. How many have witnessed this? ऐसे कभी कभी ऐसा होता है ना that you are in a dark room, थोड़ा सा विंडो खुला है, from there sunlight is coming and you can see dust particles going here and there and you can see that beam of light. दिखता है कभी कभी, है ना? You have seen this, huh? Right? Nice. Have you seen this? Nice. Tyndall effect, right? हाँ, it's horizon. Veena, correct. देखा है ना? Nice. Tyndall effect. Correct. Right? So, otherwise, light which is going in front of you, you can't see it unless there is some particles in the medium, right? So, that's why. Now, क्या होता है? This is called as Tyndall effect. Colloidal particles scatter the light. One of the easiest explanation is पानी लो, है ना? Take a torch and just shine it from the water. You won't see anything. But if you mix Dettol, soap, milk, then you will see a beam of light. That is Tyndall effect, है ना? From the colloidal magnitude, correct? So this is colloidal particles scatter the light. Now, important thing is scattering occurs due to dust and smoke particles in the air. That is what we call as Tyndall effect. They are serving as a colloidal solution, right? Now, Tyndall effect का ही reason है that you see these things. You can see in clear water there is nothing, but in colloid water, or I can say mixed with milk, थोड़ा सा, 2-4 बूंद, you are seeing the laser path. This is Tyndall effect. This is Tyndall effect. This is Tyndall effect. This is also Tyndall effect, right? All these are actually Tyndall effect only, है ना? Yes, easy, बढ़िया. Now, there is one important thing about scattering. That is the color of the scattered light depends on size of the scattering particle. Very fine particles, they scatter shorter wavelength. Larger particles scatter longer wavelength. Correct? Right? Right? Got it? अच्छा एक बात बताओ. In VibGyor, which one has shorter wavelength? Tell me, come on, jaldi. In VibGyor, अच्छा रवि, it's okay. लैपटॉप पे आप बाद में देख लिया करो ना, कोई बात नहीं. Right? Violet. Shortest wavelength is of violet in that whole spectrum. Largest wavelength is of red in that whole spectrum, है ना? I'm asking this question for a very, very important reason. ठीक है? तो अब क्या है? अगर सोचो, particles are very large. Scattered light may appear white. And this is one of the answer of why clouds appear white. Clouds are actually made up of water droplets. बड़ा मतलब थोड़ा सा बड़ा है ना, at least air से. तो वो क्या होता है? वो सारा light scatter करता है. If let's say there are 7 colors and all those 7 colors are getting scattered and reaching your eye, you will think white. भाई सारे color आ गए तो white लगेगा ना, एक सारे नहीं आए. Correct है ना? That's why. So this is the reason of why clouds appear white, because they are big particles comparatively, right? अब अगला क्या है? Atmosphere has air molecules and they are fine particles of smaller size. Air molecules, they are smaller, right? They are smaller and they are of the equivalent of the spectrum of this, है ना? Getting it? So violet क्या है? Violet and air molecules, they have almost similar size. So violet gets scattered most, blue gets scattered more, red gets scattered least. Getting it? समझ रहे हो? भाई air molecules will scatter, but the thing is, जिसका wavelength कम है, वो क्या होगा? वो scatter भी ज़्यादा होगा. तो for violet, we have understood 3 things. Violet bends the most, speed of violet is the least in the medium, है ना? And violet scatters the most. Important thing. Red के साथ क्या है? सबसे कम scatter होता है. It scatters the least, it bends the least, and its speed is most in the medium. गेटिंग दिस आइडिया, है ना? हाँ, ये सब तरीके हैं याद रखने के. दीज आर ऑल वेज हाउ यू कैन रिमेंबर. नाउ ठीक है, why is the sky blue? This is one very famous question we all ask in exams. Why is the sky blue? अब सोचो, all these are air molecules, right? Very very important animation. All these are air molecules, correct? Now when light comes, it gets scattered. What do you see? Violet or blue, they scatter the most. Getting it? They scatter the most because their wavelength is less, है ना? They scatter the most, है ना? आस्था वही बता रहा हूँ, ठीक है? They scatter the most. बढ़िया, चलो ठीक है. Now just notice over here. अभी इसके इस एनिमेशन में नोटिस करो, जो चीज स्कैटर हो गई, whatever is scattered, that reaches your eye. Whatever is not scattered, that does not reach your eye, right? अब देखो, white light आई, red orange तो आ गए, blue violet scatter कर गए, right? Blue and violet got scattered, red orange reach your eye. Sun का पता है कलर? You all must think, what is the color of sun? What is the color of sun? Tell me, come on. Color of sun. जल्दी बताओ. Color of sun. धीरज अभी नहीं, थोड़ा ना वो हो जाएगा. It's white. भावेश, you are right. It's white. It's not yellow. ना orange भी नहीं है, red भी नहीं है. It's white. Why? क्या हुआ? This, because of this you are seeing yellow, because blue and violet got scattered, बचा हुआ light sun से came to your eyes and you are thinking अच्छा sun तो yellow और red है थोड़ा सा, and blue and violet got scattered in the sky, and that is why you see the sky as blue. ठीक है? But if you think blue and violet get scattered, but sir why not we see sky as violet? This can be another question. ठीक है sir, we accept that violet and blue get scattered, we see the sky as blue, and rest of the light reaches our eye from the sun and we see sun as थोड़ा सा reddish yellowish, otherwise sun is white only. But sky violet क्यों नहीं होती? भाई अगर violet scatters the most, why not sky is violet? Why only blue? That is one question. No, the thing is your eye has cone cells, and cone cells are actually more sensitive to blue color than they are to violet or indigo. My eyes, humans' eyes, they are more sensitive to blue color, and that is why we see the sky as blue. Getting it? Very important point. This is बहुत जरूरी point है ना? Yes, violet and blue. Violet scatters the most. Blue also scatters very good. But the thing is, my eye is sensitive to blue color the most, and that's why I see the sky as blue. Otherwise, you would have seen it as violet. ठीक है? Yes. अब question आता है हमेशा ये वापस. Why does it look like astronauts always take pictures of moon at night? Moon पे atmosphere है क्या? नहीं है. Means there is no air particles to scatter the light. That is why the sky is always black. Same thing would have happened with Earth if there was no air molecules to scatter the light. ठीक है? Right? No scattering. The sky on the moon is always dark. That is why we see that it's always night on the moon. Right? Yes. So this is what scattering of light is. I'm summarizing because we have only 2 minutes. Not 2 minutes. We are actually way above the time. So today we have discussed dispersion of light. We have discussed rainbow formation. We have discussed atmospheric refraction. Alright. Gradual deviation of light as it passes through atmospheric layers having different optical densities. We have discussed Tyndall Effect, scattering, blue color of sky. Now people, अभी एक बात ध्यान से सुनो कि if you have problem today, मैं समझ सकता हूँ. This was a lot if you are learning for the first time. This was a lot if you still feel and not confident. इससे पहले we have done all the sessions very nicely, very carefully. Make sure you watch them if you have problem, because then only उसको क्या करना ना 1.25 पे देख लो. YouTube में there is a feature ना, on setting go and make it 1.25x. जो part में wherever you have a दिक्कत, wherever you have a problem, watch that part again. Make sure you understand everything well, because these are very important chapters. These are very important concepts, right? ठीक है? That's why. ग्रीन उतना नहीं होता है बिना बस, है ना? यस यस, प्रैक्टिस क्वेश्चन सब कुछ मिलेगा, डोंट वरी. इसके बाद हम लोग प्रैक्टिस क्वेश्चंस पे ही आएंगे. सो अभी क्या होगा ना, इफ यू स्टिल आर नॉट क्लियर इन क्वेश्चंस यू विल फेस अनदर प्रॉब्लम. दैट इज व्हाई आई एम आस्किंग यू, प्लीज मेक श्योर यू वॉच द प्रीवियस वीडियोस इफ यू हैव अ प्रॉब्लम. इफ यू अंडरस्टूड एवरीथिंग वेल, बहुत बढ़िया. जहां भी दिक्कत है, मेक श्योर यू वॉच द प्रीवियस वीडियोस. एंड दैट्स व्हाई वी आर टेलिंग यू, आई एम कवरिंग और वी आर कवरिंग एवरीथिंग वेरी नाइसली. यस अपर्णा, डेफिनेटली. Right? Yes, we are covering everything very nicely. end to end. You have concept capsules also, you have one shot sessions also, you have experiments also, you have shorts also. We have done a lot of things, we have given you a lot of things, but only if you are consistent, we have got you covered. I'm telling you this. And notes and everything we are giving you on the Telegram channel. In the description there is one link given to you, Telegram. Make sure you click on that and be a part of it. Channel में time pass नहीं होता है, there is no फालतू thing. What happens in that is we give you notes, we give you questions, we give you homework questions, and we tell you the schedule. That is very important, right? That's why this channel becomes very important, right? Why sky is black at night? रात में तो सूरज is down, no light is coming. रात में sky black क्यों है? इसका concept equal to shadow. Why is shadow black? Similarly, है ना? Yes, definitely Divya. Next session will be Human Eye and Colourful World, top 10 NCERT questions, 9th of August, 7 p.m. I'm telling you, this session में please come prepared, learn everything, revise everything, then come. Otherwise तो बड़ा मुश्किल हो जाएगा ये session. ठीक है? That's why I'm telling you, right? And people, this is important. Whatever I'm telling you, that is what gives you these kind of marks. If you want good marks, if you want to learn things, be regular, be consistent, watch all the sessions, तभी समझ में आएगा. ठीक है? That's why. And Trisha, you know what Trisha did, right? This is what the results we got. 2600 plus students got above 90%, means you can be one of them. You just have to know what to do, right? Be consistent, be regular, watch all the sessions, bas. Okay? Now, this is something which you all know, or you might not know. Every week, the first 1000 subscribers are getting the MLP free. It was there before. Today is not free for everyone. For the first 1000 subscribers, ठीक है? You can use the code YTFIRST. Description में एक link है, उस पर click करो. 399 का pack है. You will get it for free if you use this code. ठीक है? 14th of August को कुछ बढ़िया होने वाला है. I'll tell you. Image एक hint है. 7th of August को I'll tell you. Fine, है ना? Yes. अच्छा, you are asking this choroid, huh? Choroid. It's a bio question. And don't worry, I've asked bio team to answer this to you. All right, people. एक गूगल फॉर्म का लिंक दिया हुआ है नीचे. एक डाउट सॉल्विंग सेशन होने वाला है. There's a doubt solving session next week, which means post your doubts in that. Personal, professional, academic, whatever it is. We'll take doubts from you and take in the session. Session में I'll tell you your name, your doubt and answer to your doubt. But only if you have filled this form. इस फॉर्म में अपने डाउट डाल दो. डिस्क्रिप्शन में दिया हुआ है. ठीक है? Make sure to like, share and subscribe, people. If you think this was a helpful session, press the like button. Important, very important. Share it with your friends and subscribe if you are not a subscriber. Very important this is. ठीक है? तभी आपको पता चलेगा क्या क्या हो रहा है यहाँ पे. Yes, Divya, definitely. Don't worry. Thank you, people, for joining. Take care. Keep learning. I'll see you again. चलो, bye bye.